It wasn't supposed to fail. Not this system. Not this one. Because for years, the Iron Dome wasn't just another piece of military technology. It was something else entirely. A system people believed in, trusted, relied on. A shield in the sky that didn't just react, it predicted. Before a missile could even become a threat, it was already being tracked. Before fear could even settle in, the response had already begun. It calculated trajectories in real time, analyzed impact zones, made decisions in seconds. Not everything was intercepted, only what mattered, only what posed a real danger, which meant this system didn't just protect, it decided what needed protection. And for years, it worked. Not sometimes, not most of the time, every time. Missiles launched, alarms sounded, people froze, waiting for impact. And then, the sky answered. Interceptors rising, mid-air collisions, explosions that never reached the ground. Chaos stopped before it even began. It wasn't just defense, it was control. It was certainty. It was the reason millions of people could sleep without constantly looking up. Because no matter what happened, the system would respond. It had to. Until one night, it didn't. And that's where everything changes. Because failures like this don't start with noise. They start with silence. No alerts, no warnings, no visible malfunction, no panic, just nothing. The radar was active, scanning, watching, tracking. Targets were detected, locked, confirmed. Everything was working exactly as expected, exactly as designed. Except for one thing. The response never came. No interceptors, no launch sequence, no defensive reaction, just incoming threats and a system that did absolutely nothing. Seconds passed, then more. And in those seconds, something impossible was happening. Because systems like this don't hesitate, they don't pause, they don't think twice. They act immediately, automatically, without delay. That's what they're built for. That's the entire point. So when nothing happened, it wasn't just unexpected, it was wrong, deeply wrong. Operators were watching their screens, waiting, expecting the intercept sequence to trigger, just like it always does, because it always does. But this time, nothing moved. No launch confirmation, no system response, no correction, just silence. And by the time anyone realized this wasn't a delay, it was already too late. Because once that window closes, there is no second chance. And that's when the fear begins. Not when the system fails, but when no one knows why. Because systems like this don't just stop. Not all at once. Not without warning. Not without leaving a trace. But this time, there was almost nothing. No clear error. No visible breakdown. No obvious failure point. Just a gap. A missing action. A moment where something should have happened and didn't. And that kind of absence is far more dangerous than a visible failure. Because visible failures can be fixed, explained, prevented. But invisible ones, they raise questions no one is ready to answer. Because if the system saw everything, tracked everything, calculated everything, and still did nothing, then this wasn't a malfunction. This was interruption. And interruption means something interfered. But here's the part that changes everything. To interfere with a system like this, you don't just need access, you need understanding. Deep understanding. You need to know how it thinks, how it decides, how it reacts. You need timing, precision, control. Which means this wasn't random. And if it wasn't random, then it was intentional. And if it was intentional, then someone somewhere, knew exactly what they were doing. Because systems don't fail like this by accident. They fail like this when something makes them.
Look at the vector.
And that leads to a much bigger question. Not what failed, but who or what made it fail. Because once you start asking that, you realize something far more dangerous. If it can be stopped once, it can be stopped again. And next time, it might not just be a blackout. It might be something far worse. And that's where the real story begins. That wasn't the failure. That was the moment everything became visible. Because systems like the Iron Dome are not designed to break in silence. They are built with layers, redundancies, fallback systems, and multiple decision checkpoints that ensure even if one part slows down or fails, another part immediately compensates. Which is why what happened that night didn't just confuse operators, it unsettled them on a level they were not prepared for. Because from the outside, everything appeared normal. The radar systems were active, scanning constantly, tracking everything in range without interruption. The detection layer was functioning exactly as expected, identifying incoming threats with precision and speed. The calculation systems were running in real time, analyzing trajectories, predicting impact zones, and determining risk levels within seconds. Everything that should have been working was working. Which means the system wasn't blind, it saw everything. And that is what made the silence so disturbing. Because when a system sees a threat and still does nothing, that is not hesitation, that is not delay, and that is not confusion. That is a break in behavior. Operators were watching their screens, waiting for the usual sequence to trigger, expecting the interceptors to launch within seconds, just like they always had, because that is what the system was built for. That is what it had done countless times before, and that is why there was no immediate panic. At first, because for a brief moment, it felt like a delay, a small lag, a temporary pause. But then, seconds passed, and then more seconds, and nothing happened. No launch, no intercept, no response. And by the time the realization set in, it was already too late. To understand how unusual this moment was, you have to understand what the system actually represents. Because this is not just a defensive shield, it is a real-time decision-making network, one that continuously analyzes incoming threats, calculates trajectories, determines whether an interception is necessary, and executes that decision almost instantly. Which means it doesn't just react, it chooses. And that is where the situation becomes more complicated. Because if the system made a choice, then the question is not why it failed. The question is why it chose not to act. As initial reports began to circulate, the explanations were cautious, controlled, and limited, focusing on possibilities like technical irregularities, temporary disruptions, or unexpected environmental conditions, all of which sounded reasonable on the surface, but none of which fully explained what had actually happened. Because technical failures leave traces, they leave error logs, warning signals, system alerts, something that points to the cause. But this time, there was almost nothing. The logs showed activity, the system recorded the threats, tracking data was complete, everything that should have triggered a response was present, and yet, the response sequence never executed, which raised a more uncomfortable possibility that the system did not fail to respond. It was prevented from responding, and that possibility changed everything. Because if a system this advanced can be interrupted, overridden, or disabled without triggering alarms, then the problem is no longer mechanical, it becomes structural. And structural problems are not random, they are designed. As analysts began examining the data more closely, they noticed something unusual in the timing, something subtle but significant. A delay that did not match normal system behavior, a sequence that appeared to initiate but never completed, as if something interrupted the process at the final moment. A command existed, but it was never executed. And that kind of interruption does not happen by accident. Because in systems like this, every action is verified, cross-checked, and confirmed across multiple layers, meaning a single point of failure should not be enough to stop the entire system. Unless, multiple layers are affected at the same time, which leads to a much more serious question. What could affect multiple layers of a system simultaneously without being detected? Because that is not a glitch. That is not random failure. That is targeted disruption. And if that is the case, then the failure is not the most dangerous part of the story. The vulnerability is. Because once a vulnerability is exposed, it cannot be unseen. And once it exists, it can be used again. That realization shifted the entire conversation, moving it away from the idea of a one-time failure and toward the possibility of a deeper issue, one that extends beyond a single moment and into the structure of the system itself. Because systems are only as strong as their weakest point, and the most dangerous weaknesses are the ones no one knows exist. As more information surfaced, discussions began to shift, not just among analysts, but among those who understood how these systems operate at a deeper level, and what they were seeing did not match expectations. Because this wasn't just a delay, it wasn't just a missed intercept, it was a complete absence of response in a system designed to always respond. And that contradiction is what made it so difficult to explain. Because when something behaves in a way that contradicts its core function, it suggests that something fundamental has changed. Not broken, changed. And that is where the uncertainty begins. Because change can come from multiple sources: internal, external, intentional, unintentional. But when the change happens without warning and without explanation, it becomes something else entirely, something unpredictable. And unpredictability is the one thing systems like this are designed to eliminate, which means if unpredictability appears, something has gone very wrong or very deliberate. And that is where the real concern lies, because not in what happened, but in what it means. Because if a system that was considered one of the most reliable in the world can suddenly stop responding, then reliability itself becomes uncertain. And once reliability is questioned, confidence begins to break. And once confidence breaks, everything changes. Because systems like this are not just built on technology, they are built on trust. Trust that they will work, trust that they will respond, trust that they will protect. And when that trust is shaken even slightly, the impact goes beyond a single moment. It changes perception, it changes expectations, and it changes how people think about security itself. Because once you realize that something can fail, you begin to ask a different question. Not will it fail, but when will it fail again? And that question is far more difficult to answer, because the answer may not be known. And that uncertainty is what makes the situation so significant. Because in a world built on systems, uncertainty is the one thing no one wants. And once it appears, it cannot be removed, only managed. And sometimes, not even that.